Hey everyone, and welcome. Today we're going to build a brand new mental toolkit, one that'll help you make sense of our increasingly complex world. We're diving into something called the architecture of complexity and a really powerful idea, systems thinking.
All right, so let's get right into it. But, we're not going to start with some dry, boring definition. Nope, we're going to start with a mystery.
And that mystery is this. Why do so many seemingly good systems go so bad? I mean, think about it. Companies that look completely unstoppable, companies that are hailed as the future, and then suddenly they just implode. WeWork, FTX, Theranos, these names are practically synonymous with spectacular failure now. What on earth went so wrong so fast?
The easy answer is to just point a finger at one bad decision, or maybe a single flawed leader. But the truth? It's way, way deeper than that. These weren't just simple mistakes. They were systemic failures. The entire structure, the whole setup, was practically designed to fail. And to really get that, we need a whole new way of looking at the world.
For centuries, really, we've relied on this idea called reductionism. It's pretty simple. If you want to understand a clock, you just take it apart, right? You study all the little gears, and then you put it back together. Easy. But here's the thing. A company, or an economy, or an ecosystem, it's not a clock. So systems thinking comes along and offers a totally different approach. It says to understand the whole, you have to look at the invisible relationships between the parts. That's where the real story is.
So how do we actually start seeing these invisible connections? Well, this is where systems thinking hands us a set of brand new, super powerful lenses.
Okay, first, a really core definition. A system isn't just a pile of stuff. It's a set of interconnected elements where all the magic, all the action, happens in the interaction. Now, that famous phrase, the whole is more than a sum of its parts, what does that more actually mean? What is it?
Well, that more has a name. It's called emergence. And it's an incredible concept. Think about it. A single neuron in your brain isn't conscious, not at all. But billions of them interacting, bam, consciousness emerges. Or think about a startup's billion-dollar unicorn valuation. It's not just the sum of its desks and computers, right? Of course not. It emerges from this complex dance between its product, its team, and its market.
Okay, so to actually see this emergence and really understand how these systems behave, we need to learn their secret code. And luckily for us, there are a few key tools, think of them like decoder rings, that let us read it.
The absolute most fundamental building block of any system is the feedback loop. Now, this isn't your simple, straight line of cause and effect. It's a circle. A affects B, which then feeds back around and changes A. It's this circular causality that makes systems so dynamic and, honestly, often so unpredictable. And these loops basically come in two main flavors. First, you've got balancing loops. These guys create stability. They work to keep a system near some kind of target, just like a thermostat keeps your room at the right temperature. Simple enough. Then you have reinforcing loops. And these amplify change. They create either explosive growth or catastrophic collapse. Think of that horrible screech you get when a microphone gets too close to a speaker. Yeah, that's a reinforcing loop in action, and it is powerful.
Okay, so we've got loops, but to really truly diagnose a problem, we need to go even deeper. And for that, we have the iceberg model, which is just a brilliant tool for this. It shows us that what we see on the surface is only a tiny, tiny fraction of what's really going on underneath.
Right at the top, the little bit sticking out of the water, that's the events level. A server crashes, a quarterly report is messed. This is where most of us live our lives, right? Constantly reacting to things that just happened. It's pure firefighter mode.
But if we look just below the surface, we start to see patterns and trends. See, the server doesn't just crash once. It crashes every Black Friday. Sales aren't just down this one quarter, they've been trending down for 2 solid years. And once you start seeing these patterns, you can move from just reacting to actually anticipating what's coming next.
Go deeper still, and you find the structures that are actually causing those patterns. Why do the servers crash? Because our system architecture was never designed to handle that kind of scale. Why are sales declining? Because our incentive plan rewards signing up new people, not keeping the customers we already have. See? This is the level where we can stop just anticipating problems and finally start designing better systems to prevent them.
And finally, at the very bottom, the massive, invisible base of the whole iceberg, mental models. These are the deep, often unspoken beliefs that shape everything else. The belief that IT is just the cost center, not an investment. Or maybe the cultural belief that failure is not an option.
And this is the key. This is everything. If you want to truly transform a system, you have to get down to this level and address the underlying mental models. Okay, so now that we have our tools, we've got feedback loops and the iceberg model, let's go all the way back to our original mystery and start applying them. Because now we can see that a lot of these spectacular failures, well, they aren't random at all.
In fact, they follow these really predictable templates of behavior known as systems archetypes. Think of them as common stories that play out over and over and over again, just in different contexts. And once you learn to spot them, you start seeing them absolutely everywhere.
So let's take WeWork. This is a classic textbook limits to growth archetype. They had this incredibly powerful reinforcing loop, right? Raised money from VCs, show aggressive growth, get a higher valuation, and then use that higher valuation to raise even more money. But they slammed headfirst into a balancing loop, a limit. The operational reality of managing physical buildings just could not keep up with the explosive growth. And instead of fixing that limit, they just pushed the growth loop harder and harder until the whole thing came crashing down.
And what about FTX? This is a perfect example of eroding goals. The stated goal, the one on paper, was to be a regulated, trustworthy crypto exchange. But as the gap between that goal and the messy reality started to widen, they didn't fix the reality, they just quietly lowered the goal. The internal mental model shifted. Huge, serious problems were dismissed as, oh, it's just a liquidity mismatch. The system standards just eroded and eroded until there was basically nothing left.
So seeing these patterns is incredibly powerful. But, diagnosis is only half the battle. The real goal here is to know how to actually fix these problems. Where in a complex system should you intervene to have the biggest possible impact?
And this brings us to the amazing work of Donella Meadows and her idea of leverage points. Now, what's so fascinating here is the illusion it exposes. Most of us, most of the time, we spend our energy on low-leverage interventions, changing some numbers, tweaking parameters, shuffling personnel around. It feels like we're doing a lot, right? But the actual impact is tiny. The real leverage, the high-impact points that can change everything, lies much deeper in the system, changing the rules, the information flows, and ultimately changing the very goal of the system itself.
And that brings us to the biggest, most complex system we are all currently trying to build. One where understanding these leverage points isn't just an academic exercise. It might be existential. Of course, I'm talking about artificial intelligence.
You see, AI alignment is the ultimate systems thinking problem. It is a classic cybernetics challenge, that is the science of control and communication in complex systems. The question is, how do you design the feedback loops, the rules, and most importantly, the fundamental goal of a system that will very soon be vastly more intelligent than its own creators? This is, without a doubt, the highest stakes design problem in all of human history. Which leaves us with one final, crucial question to think about. As we build these incredibly complex systems, we have to ask ourselves, are we designing them with the wisdom to ensure they serve our goals, or are we just creating powerful reinforcing loops that will eventually spiral completely beyond our control? The choice, for now, is ours, but only if we learn to see the system.